Hello everyone. Today, we will learn the basics of programming for Arduino UNO. With programming, Arduino UNO can perform functions such as LED blinking and motor control. In the upcoming lessons, we will start with fundamental programming operations and gradually move on to motor control, helping you master these core skills with ease. The Arduino series development boards support various programming software, such as the official Arduino IDE, the powerful Platform I/O, and Scratch for Arduino, which is suitable for beginners. With these tools, we can easily write and upload code. To provide a more intuitive demonstration, this lesson will use Tinkercad for simulation. Place the Arduino UNO R3 on the workspace. Click the Code button in the upper right corner. Change the editing mode to text. Then, modify the code as needed. Arduino code is usually divided into three parts: definition, setup, and loop. The definition section includes libraries and variable definitions. For example, a variable LED_pin equals 13 is defined here, indicating that the LED is connected to pin 13. Arduino UNO comes with an onboard LED, which is connected to digital pin 13 by default, referred to as the L indicator. Setup is an initialization function that runs only once when the system starts or resets. In this example, pin 13 is set to output mode to control the LED's on-off state. Loop is the main loop function, which executes repeatedly and indefinitely. Here, the pin is set to high, turning the LED on. Then, it waits for 1000 milliseconds or 1 second. After that, the pin is set to low, turning the LED off. It waits for another second, and the cycle repeats. With this code, the LED on pin 13 of the Arduino UNO will blink every second, repeating infinitely. Next, we will learn how to use Arduino UNO to control motors. In Lesson 12, we used switches to control the motor's high and low signals. Today, we will remove the switches and the 5 volts power supply, and instead use Arduino UNO to control the motor's movement. Place an Arduino UNO on the workplace. First, connect the 9 volts power rail of the upper part of the breadboard to the VIN pin of the UNO to power the UNO. Next, connect the 5 volts and GND pins of the UNO to the lower power rail of the breadboard to power the breadboard. Then, connect the 3A and 4A pins of the L293D to the D2 and D3 pins of the UNO, and the 1A and 2A pins to the D4 and D5 pins, respectively. Finally, modify the code. First, define the positive and negative terminals of the two motors as digital pins 2, 3, 4, and 5. Then, set these 4 pins to output mode. Next, in the loop function, set pin 1 of the two motors to high and pin 2 to low. At this point, the motors rotate forward, and the car moves forward. After a delay of 2 seconds, set pin 1 of the two motors to low and pin 2 to high. At this point, the motors rotate in reverse, and the car moves backward. After another 2-second delay, the cycle repeats. Therefore, the function of this code is to make the car's wheels move forward for 2 seconds, then move backward for 2 seconds, and repeat the cycle. Next, let's enable the enable pins to control the motor speed. Connect the 1, 2 EN pins of the L293D to the D9 pin of the UNO and the 3, 4 EN pins to the D10 pin. Both of these pins support PWM. Then, define variables. The left motor is connected to digital pin 9, the right motor is connected to digital pin 10, and the speed is set to 100. Next, set these two pins to output mode. Finally, add code in the loop function to set the speed of the enable pins, thus controlling the motor speed. You can practice with the components provided in the Clear Robotics Kit to see if your robot can move forward and backward at a constant speed. We have already achieved forward and backward motion for the car, but how can we implement steering? This is where differential drive comes into play. Differential drive is a common drive system for mobile robots and vehicles, widely used in two-wheeled robots, small intelligent vehicles, electric wheelchairs, and more. Its core principle is to independently control the speed of the left and right wheels to achieve forward, backward, turning, and other movements. When the left and right wheels rotate forward at the same speed, the car moves straight forward. When the left and right wheels rotate backward at the same speed, the car moves straight backward. When the left wheel moves forward and the right wheel moves backward, the car rotates clockwise. When the left wheel moves backward and the right wheel moves forward, the car rotates counterclockwise. When the speeds of the left and right wheels are different, the faster side determines the direction of turning and the radius of the curve, allowing the car to move in a curved path. Let's modify the code to make the robot turn right. Remove the backward motion code from the loop function. Then, set pin 1 of the left motor to low and pin 2 to high. Start the simulation and you will see the left motor rotate forward and the right motor rotate backward, which makes the robot turn right. Similarly, you can practice with the Clear Robotics Kit to see if your robot car can turn right. In this lesson, we learned the basics of Arduino UNO programming, including LED control, motor driving, and differential drive implementation. Through simulation and experiments, we mastered how to control hardware using code. In the next lesson, we will explore the basic principles and functions of the Bluetooth module, preparing for the implementation of wireless communication control with Arduino UNO.